Guys, just a quick refresher on the stuff that we covered yesterday. We talked about this idea of talking about equations in two-variable form, and we said any equation with two variables is an equation with two variables, two different variables. And I don't remember what I used for the example up here, but I might have something like y equals 3x minus 5, and yeah, I know you already have something written up there, but this is in two-variable form because there's an x and a y within the same equation, right? Everybody agree with that? Okay. We talked about the solution of an equation in two variables, and we'll talk about that here in a little bit more, but a solution of an equation in two variables wants to know, is a point a solution to this, okay? And I think that one thing that I'll talk about here real quickly is this, and show you one way of checking this is the following. I think yesterday, did we say yes or no to this example yesterday?
We said yes.
We said yes, okay. We wanted to answer the question, is this point right here, 5, -1, a solution to this equation right here, okay? And the way that we checked was the following. We have this ordered pair 5, -1, and 5, -1 is written in a form of x, y. So what this is really telling us to do is to take 5 and plug it in for which variable? X. And this is saying take -1 and plug it in for what? Y. So what we did yesterday was we said, okay, in for x right here, in this x minus 3y equal 8. We're going to plug 5 in for x, right, guys? And then we had a minus 3. And notice how every time I substitute something in for the variables, what do I put around it? Parentheses. What's going to take the place of y in this? What's going to take the place of y?
Y is going to be
-1, wasn't it?
Yeah.
And the equation was equal to 8. So help me out here. Here we got a 5. Guys, right here, the -3 and the -1, I can multiply a negative and a negative together, couldn't I? What's a negative times a negative going to get me?
Positive.
Positive, isn't it? So this -3 times -1 would really become plus 3, wouldn't it? Guys, what's 5 plus 3 add up to on the left side here? 8, right? So here we get 8 is equal to 8. When I have that comparison, 8 is equal to 8. Statement true or false right there?
True.
That's a true statement. Now I've got one number on the left, one number on the right. We've got a comparison. This is a true statement. So since that statement is true, that means that the point 5, -1 is a solution. Now something I want to show you here quickly is this. What was the order of this down here? Was it yes, no, yes? Okay. I want to go back here. We didn't get a chance to talk about this much yesterday because we had a few problems, and I think this might clear up some things here. But guys, I want you to go into this right here. I want you to go into your Desmos calculator. And here's what I want you to do. First of all, that example one that we looked at, what was the equation we talked about there? Was it x minus 3y equals 8?
Yeah.
So up here in this first field, just type that in. X minus 3y, whoops, x minus 3y equals 8. Whoops, not 9, Parson, 8. Okay, that gives us a line. And we'll talk about how we get those lines here again. We looked at it yesterday, but that there would be an equation for that line. Now, is there anybody that's having trouble getting that line put in there, first of all? Anybody having trouble getting that in there? Okay, what point in that example one were we asking to see if it was a solution to that equation? The point was what, comma what? 5, -1. So I'm going to come down here to field 2. See how I'm down here at field 2? I'm just going to type my point in here. Parenthesis 5, -1. In this calculator, we'll go ahead and plot points for you. And I guess that the one thing we already know, mathematically we already know that 5, -1 is a solution, right? And this was the line formed by the given equation. Agree there? Where does that point fall? Does it fall on the line or not on the line?
On the line.
Guys, this is a collection of points. This red line is a collection of points that's going to make this true up here. Okay? So if I could snapshot this right here, let me do this quickly, take a quick snapshot of it. And I'll write on this thing. If if you had a graphing tool like this, and I said, okay, I got a question. How about this point 8 comma 0 right here? Point 8 comma, ooh, that's a pretty picture sound. Is that point on the line or not on the line? It's on the line, okay? So my question becomes this, is 8 comma 0 a solution to that equation? Would you say yes or would you say no? Would you say yes? How about the point 0 comma 4? 0 comma 4 gonna work up here? Well, 0 comma 4, right up here, up top, be a solution to this equation. No, it won't be because it's not on the line. So if I go back and take a look at what we're doing here, if I go back and take a look at the on your owns up bottom, what was the equation for the on your owns, guys? Clean this up here quickly.
0, comma, -5.
Okay, but what was the equation up above the three problems? There was like
2x minus y equals 5.
2x minus y equals 5. Okay, so that's the line right there that we would have gotten if we would have made an input-output table, plotted some points. What was the first point we were checking?
0, comma, -5.
Was 0 comma -5 a yes or a no, kiddos?
That's a yes.
So it was a yes yesterday. So if 0 comma -5 was yes, should this point be plotted on the line or off the line?
On.
What do you think? Are we good right down here?
Yeah.
Everybody agree? What was the next point? What did we say on the next point?
3, comma, 2.
3 comma 2. Uh-oh. Is that point on the line?
No.
What did we say about the point 3 comma 2? Solution or not a solution? Anything that falls off the line is not a solution, right? That's where the saying toe the line comes into play. Did you know that? Your parents ever said, hey, toe the line? Pretty sure Walter White said that a time or 10. Toe the line, right? Right, Mrs. Miller?
Yes.
I'm the one who knocks. I am the danger. What was the last point?
-2, comma, -9.
-2 comma what?
-9.
What do we say?
Yes.
Yes. Can't see it here, so I might have to zoom out, or I can drag my screen. Oh my gosh, is -2, -9 on that line?
Yes.
You understand how to use this to help out? Okay. Questions about that first page then? Okay, let's jump into the second page quickly, kiddos. Just a quick review on second page. We talked about how do we graph these right here. Okay, I told you to rewrite this top equation up top here, and I said call this y equals,
Negative x plus 1.
and we call it negative how many x, Seth?
1x.
Very good. Okay, so first of all, is that in one variable form or two variable form? Well, I guess it doesn't matter because I'm going to change the bottom anyway today. We said in order to graph this linear equation right here, we're going to form an input-output table, right? I said we're going to choose our inputs the other day. And I said, what do you want your inputs to be? What do you always want your inputs to be unless I give you something different? What values do we choose if they don't give them to you?
0, 2,
0, 2, and what?
4.
All right, so right here, guys, let's do the first one. What am I going to plug in? Well, I'm going to plug 0 in for x, right? Okay, so up here I'm going to rewrite the equation, and everywhere where I have an x, the first thing I'm going to do is put a 0 in. So this is going to become y equals -1 times 0 plus 1, right? So over here I can calculate all this. What's -1 times 0? 0, and add one more, you've got 1. Okay, so what's that mean about your y value here when I input 0? Y would be what? 1. Okay. Now, second one, let's plug in instead of plugging in 0 here, let's plug in what value? Well, 2, right? So I've got y equals -1 times 2 plus 4. Right? What's -1 times 2, kiddos?
What?
It's -1 times 2.
Oh, -2.
-2 plus 4 more is?
-6.
Nope. It's -2 degrees out and it warmed up 4. Where are you at?
Oh,
+2. Good. Okay. So when I input 2, what's my output right here? When I input 2, what's my output? 2. Okay. What's the last input I want to make? What's your last input here?
4.
Got to input 4. So where there's an x up here, instead of putting 0 or 2 in, we're now going to put in a 4. So in my original equation, I've got y equals -1 times 4 plus 4.
Yeah. We need 1 on the end.
Yeah, I made a mistake up there, didn't I? I'll back up here. I added 4 right here. We should be adding what value on the end? Okay, so let's go back to here. This should be +1. My mistake right there. I thought something looked goofy there. Okay. Let's back up on this one. What's -1 times 2 again?
-1 times 2 is
-2 plus 1 more would put us -1. Good, right. There we go. Okay. Now that I've got myself on track, got a case of the Mondays on a Tuesday. What am I plugging in now, guys? What value?
4.
Okay. And then +1 on the end, right? What's that value going to get you?
-4.
-4 plus 1 will be -3. Okay, so what we've essentially done here, guys, is this. We've put 3 values in. We've got an x value, we've got a y value. Okay? Now what we're going to do is to say, you know what, these are points, x comma y. We're simply going to plot them. So what's the first point I'm going to plot, guys? What comma what?
0,
0 comma 1. Isn't 0 comma 1 going to lie right there on your graph? You guys agree? What's the next point I'll plot then? 2 comma -1. Write 2 down 1. Now guys, you'll know you've done this correctly if your 3 points are in alignment. If it looks like it forms a triangle, something's wrong. What's the last point you're going to form? Or plot, I should say.
4,
Write 4 and down 3. 3, 4 down 1, 2, and 3. Okay. First question, do those 3 points that I plotted look like they're in alignment?
Yeah.
Okay, so, here you go. With your straight edge, I'll get my straight edge out. Draw this line. Looks like to me, this is what we're going to end up with. Something that looks like that. Okay? So that would be the graph of the line. Now where could I check to see that I've done this maybe correctly? Well, couldn't I come into here? And I'm going to reset everything. And I'm simply going to type in here y equals. Simply type in here y equals. What was the original equation? -1x plus 1. Was that right, guys? In Desmos calculator, does that line look somewhat like what we've got on our graph right here? You guys agree with that? Okay. So if you're ever given an equation right here and they say make a graph of it, what do I want you to choose for your inputs if the inputs are not given?
0 to 4.
Plug those in, figure out what the y values are. You'll have your 3 points, plot your 3 points, and draw. Okay, let's run back to this horizontal and vertical stuff again quickly. Guys, horizontal and vertical lines are no longer in 2 variable form. They're actually in 1 variable form. And I think we could do this the same way. Here it says, in this first one, the equation's y is equal to -2, right? Whoops. Equation's equal to y is equal to -2. Okay? I could do this the same exact way. Now, this is what we said was a horizontal line yesterday, right? Now, what this is really saying is the following. If I would set an XY table up for something like this, this here says no matter what your x value is, your y value is always going to be what? -2. So I don't care what x is. X could be a bunch of different values. But according to this equation right here, y can only be what value? -2. So I might have a point 0, -2. I might have a point 2, -2. And I might have a point 4, -2. Again, I don't care what the x's are, as long as my points that I have up here are the following. These have to be what value in the right-hand column?
-2.
Why do they have to be -2, guys?
That's so y equal.
That's what the equation says to do. So no matter what, y has to equal -2. And think about it, guys. 1 point, 0, -2. If I plug this point in up here, well, there's nothing to plug in for x up here, is there? But I could plug my y value in. Would you get a true statement up here? You would, wouldn't you? So what's the first point I've chosen to plot right here, kiddos? 0, comma what?
0, -2.
Boom. What's the next point I would have to plot, given what I've got?
2 negative.
Right 2, down 2. Boom. What's the next one I've got here?
4 negative.
4, -2. Right 4, down 2, right? Holy cow, looks like to me these 3 points are going to form me what kind of a line?
Horizontal.
It's going to be horizontal. And isn't that what we talked about yesterday? That would be a horizontal line there. So what I'm saying is this. Anytime you have either a horizontal or vertical line, look at your equation and say, okay, the y value always has to be what?
Negative.
Can I pick some x values then?
Yeah.
Can't I? So this would be a horizontal line. Fratsky, you all right, buddy?
Yeah.
How's the other guy look?
You don't want more.
We're working on those notes from yesterday, so if you find them, that's great. But if you can't, I'll help you out. You got a nosebleed, bud?
Yeah.
You need a nurse or anything?
No. That's why I was late.
Okay.
I've
Did
been
you
late
check in with
lately.
the office, or do I need to change attendance?
I checked in with the office.
Okay.
I got a pass right there.
Okay. Oh, okay. Go to Texas and you come back bleeding and nose.
No, I
Just
checked in
the
the other
other
place
guy.
in Texas, like really bad.
Yeah.
And now I'm like, I filled up a whole towel this morning. My mom thought that she's gonna take me to the hospital.
Yeah.
And now I just it hasn't stopped bleeding. It probably
Well, you make sure you take care. Are you lightheaded or anything?
No, not yet.
Okay. Well, if you start feeling funny, you let us know. Okay.
Alright.
Okay. All right. Let's look at this next one right here, guys. The other equation that they talked about relating to vertical and horizontal lines is the following. They say, you know what, we want to graph x is equal to 3. Guys, if I give the equation x is equal to 3 right here, what must be true every single time?
It has to equal 3.
Your x value is always going to be 3, right? So if I make an xy table, what values am I allowed to change, the x's or the y's?
X is, no, y is
Can change the y's. The x has to be 3 comma something, right? Let's go 3 comma 0. How's that sound? Good there? Okay, next point. The x value has to be what according to this equation right here?
3.
So let's pick 3 comma a different value other than 0. How about 3 comma 2? Is that okay? Let's pick one more point so I know I have 3 points. Hopefully they're collinear. How about 3 comma 5? Is that okay?
Yeah.
Right here, kiddos, it says, I want to graph the equation x equals 3, which implies that, you know what, you can choose any point as long as your x value is always what?
3.
X equals 3 implies that all the x values are 3. Up here, y equals -2 implies that all the y values are what? Go back and apply your points. First point is 3 comma 0. Right 3, up 0. Boom. What's my next point?
3 comes 2.
Right 3, up 2. Holy cow, what kind of a line does this appear to form already? Okay, why did I say holy cow? How come I didn't say holy horse? 3 comma 5. Right 3, up 5.
Because cows make cheese.
Isn't there, there's a story behind the saying holy cow, and I'm not sure what it is.
Originally, it was supposed to be Holy Brangus, since they used to sacrifice cows to gods, and cows back then were known as Brangus cows.
Yeah?
Now we have the species, well not species, more just the type of cow called Brangus, and then we just have the regular old cow.
Neat. Okay, you understand vertical horizontal lines here then? Okay.
That line is not vertical.
What's that?
I'm leaning.
Oh, you want me to unlean it?
Yes, please. Got
Got it?
Yeah.
Okay. Mason, I love it when people pay attention to detail, so thanks for pointing that out.
You're welcome.
Okay, so what I want to get onto is the last page, and the last page is where things can kind of get tricky here a bit. Guys, if you'll take a look at the first page of your notes, example 4 is all about writing everything in function form, okay? take a look at the first page of your notes and go into your vocab and ask yourself or remind yourself what function form was again by definition. Define function form from yesterday's notes. What's it say about function form?
An equation where it's y alone.
We got to get y alone, right? Okay, here's the deal. I'm going to kind of give you some rules to this. Show you how this works. Okay, I'm going to kind of make a chart right here. When we write stuff in function form and then graph this stuff, here's how it works. Function form means we want y is equal to something. Function form means that y is going to equal something, all right? So if you notice up here, there's going to be an equal sign. There's going to be y equals and blah, blah, blah. Over here, do you have just y and just equals anything over here at all? Do you have that or not? Well, take a look at the left-hand side of the equal sign in this equation. Is y all alone or is there something with it? There's something with it, right? Agree with that? Okay. So I'm going to make a list of rules up here as to how to handle this, okay? Here's how this is going to work, and we'll look at a couple of examples. Rule number 1. Ask yourself, is y positive or negative? Is the y in the problem positive or negative? Okay. What kind of y do you have in that problem, guys? Negative. Okay. Here's what I'm going to say. If it's positive, leave it alone. Okay. If it's negative, we're going to write switch all signs. Okay, so that's rule number 1. Let me show you why we might consider switching signs if something is negative. First of all, guys, when I get y alone, do I want a positive y here or a negative y sitting right there? I want a positive 1y sitting there, no negatives. All right. Here's a question up here on the board in green. True or false? True. Positive 6 equals positive 6, right? In that equation, if I switch every single sign, positive 6 and a positive 6. If I switch this positive to a negative and I switch this positive to a negative, true statement or false statement? Still true. So if I switch every single sign, the equation is still going to be what? True. So the thing I'm telling you to do here to get into function form is the following. I'm saying, look at your y value. Here it is. I'm asking the question, is that y value a positive or a negative?
Negative.
If it's a negative right here, what are we told to do? Switch all the signs. So I'm going to take this equation and do that. Your 3x initially was positive, right?
Yeah.
So what are we going to change this to when we rewrite it? Okay, so step 2, here it is. We're going to rewrite this because y was negative, okay? Now are you always going to have to rewrite it?
No.
If y is positive, then do what? Leave it alone, and I'll tell you where to go here. But we're going to rewrite. So the 3x's become what kind of 3x, kiddos?
3x negative.
Negative 3x plus what?
Plus positive y.
Equals what kind of 2 now? Negative what? Okay. All I've done is taken every positive and negative sign and done what to them? I switched them because in the very beginning of the problem, the y was what kind of a value?
Positive.
Well, y initially was
Negative.
negative. We want in the end to make it a positive. Okay. Now, if you have to rewrite it, and I might maybe put like number 2, if necessary, right? Okay, step 3. Here comes step 3. Squeeze this in here today. Step 3. Move anything with an X in it to your other side. Again, function form means to get what alone, guys?
Y.
Means to get y alone, right? If I've had something like this in the past, if I had maybe, oh, I don't know, 3x plus 4 equals 8, how would you solve this first? What would you have to do to both sides? You would subtract a what?
Subtract 4.
Right?
Yeah.
So what do the 4's end up doing here?
Cross even out.
We have 3x equals 4. Well, the same thing is going on right here, guys. I'm trying to get y alone. If I want y alone, I don't want any what with it? Don't want any x's, do you?
No.
Okay, so here's the deal. How am I going to get rid of a negative 3x here now if I want to move it to the other side? Well, wouldn't you add 3x here? How do you get rid of a negative 3x? What's the opposite of subtracting? Adding. If I add 3x here, what's adding a 3x to this going to do?
Add 3x to the other side.
This and this would do what to each other then?
Oh, cancel.
Cancel. If I add 3x to the left, you'd have to add 3x to the what?
Right.
Okay, no. Kind of keep that in mind. If I get rid of the 3x's over here, is y alone on the left side?
Yes.
It is, isn't it? Okay. Guys, the 3x initially on the left was negative, but I moved it to the other side. Now it's a what?
Positive.
It's a positive. So I think that what I'm going to tell you to do is this. Oops. Yeah, that's good. I'm going to say move to the x to the other side, but a negative 3x on the other side will become what kind of 3x on the opposite side? You know, positive, wouldn't it?
Yeah.
So if I take something and move it to the other side, what do you have to do to the sign if you move it to the other side now? How do you undo a negative 3x?
You add.
Add a 3x. Disappears here, you add 3x over here. So what I'm saying is this. If I take this and move this part right here to the other side, it wouldn't be negative over here on this side. It would now be what?
Positive.
Positive. When you move it to the opposite side, the sign's going to switch. Okay? So what we're going to end up doing here is moving this to the other side. Becomes negative 3x. But then negative 3x will become a now positive 3x. So if I move any x's to one side or the other, what do you got to do to the sign?
Switch it.
Okay, so maybe in here, move x to the other side and switch. And do what? Switch its.
Sign.
Alright, so let me show you what we've got here. When I took that negative 3x that was here and moved it to this side, we end up with the following equation. By the way, is y all alone now?
Yes.
What are we going to say y is equal to in this now?
Y is equal to
Negative 2 plus what?
plus 3x.
Okay. We're going to do another example here together. Y equals negative 2 plus 3x. Now, it says after you've gotten your equation in function form, and I know I'm in function form because what, guys?
Y.
Y is all alone. I want to show you something here real quickly. How do you know if that's right? Well, let me show you this. If I go into Desmos, you don't need to do this, just watch. Guys, what was the equation originally up in the type part of the problem?
Equation originally?
Yeah, wasn't it 3x minus y?
Yeah, equals 2.
2 or negative 2?
2.
Oh, it was 2? Why did I put a negative in there?
You said.
Oh, yeah. Making sure you're listening. Right person. What do we get for an answer, kiddos? Y equals negative 2.
Negative 2 plus 3x.
If we've done this correctly, the original line of the original problem is the red line. I'm forming a new line that's a blue line. If I've done function form correctly, where should that blue line fall? Right on top of the red line. Okay? Negative 2 plus what here?
Plus 3x.
Oh, did it work?
Yes.
Okay, so how do I know my function form is right in the end? What can I do?
The line goes.
Well, type in what you had originally,
Yes.
right up here. And then once you've got it in the function form down below, if you've done this correctly, this blue line should take and cover up your what?
Red line.
Red line. Is that what happened here?
Yes.
So function form has to be correct here, right? Okay, so let's try one together. Let's see if we can't get one in function form together. You guys have your rules in front of you. I'll come back to the graphing part of this in a second, all right? But I want to get function form down first, okay? Okay. Mrs. Miller, give me something in standard form. Give me something with a coefficient other than 1 also on y.
Okay, on Y,
Yeah.
well, let's go, I'll do odds or evens. 4x plus 2y, is that what you want?
Perfect.
Equals, what's a good number?
14.
14, okay.
Okay, guys, is that function form or not function form?
Function, not function.
Why is that not in function form? What's not alone?
Because y is not alone.
Y is not alone. Okay? So I want to put this in function form. All right? So look at your rules. What's the first question you need to ask yourself?
Is it positive or negative?
Is it positive or negative? Is the Y positive or negative? Look at it. Is Y positive or negative?
Positive.
So positive 2Y, right? Positive 2Y, right? Okay? So do I need to rewrite it or not? No, leave it alone. Step 3 then, get the what out of there?
Get the 2.
No.
No, the 4.
What's it say? Read your directions.
Rewrite.
You didn't need to rewrite. Everything was positive, right? What do you have to move? If you want Y alone, what do you got to kick out of there? Got to kick 4x out. I'm going to take 4x and move it to the other side, guys. If I move the 4x to the other side, it's positive over here already. What's it going to be if I move it to the other side? So this will be 14 plus or minus 4x. Guys okay with that? Move the 4x to the other side. Guys, is Y all alone yet?
No.
I would like this to read 1y. That says how many y?
2.
2y. Well, how do you get rid of the multiplication of 2? What's the inverse of multiplying by 2? Dividing by 2. So if you've got a number out front of the y right here, in this case it's a positive. Can I take everything in here and divide it by what? 2. Do that. Divide everything now by 2. Divide this by 2. Divide this by 2. Divide this by 2. What are the 2's going to do here?
Cancel each other.
Leaving us with what?
Y.
A y alone. That good or that bad? That good. That real good.
Okay.
What's 14 divided by 2 right there? What are you going to have here when you divide this out? 7. Touchdown Vikings. All right. What's the last part going to be?
That'd be 2.
Minus 2 what?
X.
There it is. Okay. First question you ask yourself, is the y positive or negative? This time y was positive, so do we need to rewrite or just leave it alone? Leave it alone. Okay, then we took this 4x, which was positive over here, we moved it to the other side and made it what kind of 4x? Negative. Now, we had the situation here where there was a coefficient in front of the y. Last step then was to divide everything by that coefficient. So divide every little part by 2. When we're done, y equals 7 minus 6. Hey, how do I know I'm right, guys?
And
How do I know I'm right?
the red line, the blue line.
I'm going back here.
Cross.
Blue line over red line, right? Mrs. Miller originally said the equation was 4x plus what?
Plus 2.
Yep.
There it is. 4x plus 2y was 14. There's her graph. We wanted to rewrite that in function form, so we had y alone. We said y equaled what here, guys? 7 minus what?
7 minus 2.
2 what?
X. That works.
Works. Okay? Works. All right. So why is function form important? Well, let me show you why. I'm going to go back to that problem we were working on. Right here, kiddos. Right up in here we had said y equals -2 plus 3x, right? Now I can get a graph on a computer, that's great. But now what we want to do is, it said to put this in function form here, and then do what?
Graph.
Graph that. Okay, so to graph this right here, first of all, is this one variable or two variables up here? Two. So I'm going to make my chart right here. We're going to input some x values. What do you think I'm going to choose for my inputs? What am I choosing for my inputs? 0, 2, and what? 4. Okay, help me out here, guys. I put 0 in right here. What's 3 times 0?
3 times 0 is 0.
So -2 plus 0 would make -2 for the y value. Function form makes it where I put an input in, I can just figure out, okay, put my input in, calculate the number, and boom, you've got your y value. Okay? Getting y alone helps us get x, y values to plot our points. How do I plug 2 in here? What's 3 times 2 right here, kiddos, when I plug that 2 in for x? 3 times the 2. I'm plugging in 2 for x, right?
Yes.
What's 3 times 2?
6.
6. And then 6 minus that 2 would be what? 6 plus -2.
6 plus -2 would be.
Anybody?
Wait, what?
Oh,
6
4.
minus 2. Thank you. When I input 2, what's my output? 4. Okay, I'm going to take 3 now times what input?
4.
What's 3 times 4?
12.
12. 12 minus 2 would be what?
10.
Okay, so the points I'm going to plot, 0, comma what? 0, comma what?
-2.
0, -2. Okay, and then the next point I would plug in or plot would be 2, comma what?
4.
Right 2, up 1, 2, 3, 4. Okay, the last point I plug in would be 4, comma what?
10.
I'm going to go off the chart here a little bit, but I'm going to go right 1, 2, 3, 4, up 1, 2, 3, 4, 5. 5, comma 10 would be right about here on the graph where I'm at. What does it look like? Those form a line for me when I do that?
Yes.
Okay. Now again, there's a lot of stuff going on here. When it says get something in function form, what are you trying to do, guys? Get y alone, right? Your recipe for getting y alone is to first of all ask yourself, okay, is y positive or negative? Depending upon these two results right here determines if you rewrite it or not. After you've got what you're working with here, what's it say to do to the x value?
Move x to the other side.
And do what with its sign?
Switch its sign.
Switch its sign, okay? There was a case where we had like 2y in the beginning. The last step would be, if I had to add a step 4 to this, I'm going to put it down here. If there was a step 4 to this right here, I would write down divide if what? Well, divide if necessary, right?
Yeah.
Okay, divide if necessary. Okay. All right, I'm not too worried about part A up here. What I would like to do is this. I'd like to kind of go over part B together and be able to do this right now. Okay. Part B, I think if you can handle part B today, we'll be in pretty good shape. So you might want to star this one. This is a pretty big example, pretty important. Okay, so the directions up there for part B, I'm going to say we want to take the following equation, x minus 2y equal 4. Put that in function form and then do what? Graph. Okay, so we're going function form first. All right, what's my first question, kiddos? Is y positive or negative? So you help me answer that, Candace. Is y positive or negative? It's negative. So what do I need to do? Leave it or rewrite it? Rewrite it. How would I rewrite this, guys? What kind of x is this in the beginning, gang?
Oh, negative.
So it'd be negative x plus 2y to rewrite it, right? Equals what kind of 4 now?
Equals negative.
Switched all the signs. So now we have y as a what? Positive. Okay. Gotten the y as a positive. Now we need to kick x out. Kick x to the other side. X on the left is negative, so what's going to be on the right?
Positive.
So if I kick this out, or say, you know what, let's get this to the other side now. Boom, we're taking this to the other side. And we're going to change that negative x to a what?
Positive x.
That didn't work out the way I wanted it to. So we have a plus 2y equals, we're going to change this negative x to a what now?
Positive.
Okay, we move it to the other side. Everybody agree? Is there a coefficient to y, or is y all alone now?
Coefficient.
What do I have to divide everything by?
2.
Divide by 2, divide by 2, divide by 2. Let me show you what's going on here. Guys, how many x is this right here?
1.
1x, right? Let's divide. The 2's are going to do what here?
And cancel in half.
You're going to cancel. So you have y equals. That's good. Y equal. That good, right?
Yeah.
Function form. We've gotten to function form. What's negative 4 divided by 2? Negative 2. Okay, I don't care how you write this right here, but you've got 1x over 2. I would leave stuff as a fraction if I were you guys. Do you guys agree that this is really plus 1/2? You understand where the 1/2 is coming from?
Yeah.
1/2 times which variable? Okay. Now one thing again, like I said, I would encourage you strongly to do. Make sure you know function form is correct. And you know how to check to see if function form is correct now, don't you?
Yes.
Okay. So in your calculator again, type in x equals, clear these out. Type in what was the original equation, Mrs. Miller?
It's x minus 2y.
X minus 2y
Equals 4.
equals 4. And then the next one we got as function form was y equals.
Negative 2 plus 1/2 x.
Nice thing I like about this Decimalist calculator is it puts fractions in here. However, you got to be careful not to put the x in the denominator. Okay, look at that hyperbola you get. We aren't talking about hyperbolas yet, are we? We don't want hyperbolas. You see something like that, you should be like, oh, and freaking out. Although you would really like to know that that's a line of symmetry for that parabola right there, which is pretty gosh darn cool when you're talking about finding lines of symmetries for hyperbolas. But we'll get to that someday down the road. Make sure, see how my cursor is blinking in the denominator there? I want 1/2 x, right? Do you see how my cursor is blinking in the denominator up there? Push your arrow key to the right so your cursor goes to the right of the whole fraction. And then we're going to put an x in there. Guys, does the blue line cover the red line?
Yes.
So is my function form correct or incorrect?
Correct.
Has to be correct, right?
Oh my.
That one kind of hurt. I'm not going to lie. So function form is correct, right?
Ah.
So what do we have to do now?
The graph.
The graphing thing. So we're going to form a table. What am I going to choose as my inputs? What am I going to choose for my inputs? What values?
Oh, 1/2.
Ah!
0, 2, 4.
0, 2, 4. Who do we appreciate? 2, 4, 6, 8, but that's okay. You could have gone 0, 2, 4. Who are we cheering for? I like it. Wait, you don't like it? You think it's corny, don't you? Alright, I'll go back to the drawing board. Wait, I'm at the drawing board. What am I going to insert for x first? 0. Okay, what's half times 0, guys? What's half of 0? 0 plus negative 2. What do you get? Negative 2. 0, negative 2 is a point we're going to plot. Plug 2 in. What's half of 2 now? Half of 2.
Half of 2 is 1.
1 plus negative 2 is
Negative.
negative 1, right? Hey, check this out. Plug the 4 in. What's half of 4? 2, right? 2 plus your -2. What is that?
Zero.
Got some points to plug in, right? 0, -2 is right down here. Down 2 units. My next point, right 2, down 1. My last point, right 4 and up 0.
Nope, that's 3.
My points in a line. Are my points in a line?
Yes.
Okay. Again, guys, I get that this is not the easiest stuff in the world. This is pretty tough stuff, okay? And I know part of your problems on the book page, which I think said due tomorrow, right?
Z.
Let me get this graph paper out for you. You're gonna need 1 sheet of graph paper to do your assignment. So anytime it says to graph something, put your graphs here. Is that okay? All right. Somebody had that assignment handy for me in terms of the numbers that we're doing.
We are doing.
Hang on one second, Mason. Let me get this handed up first, and then we'll talk about what we're gonna do here.
Yes. I got 25 free points on Disney. Yes.
Okay, this will be the graph paper for the book page that I assigned. I want to make some changes here today first.
Should I
So,
answer that question?
what's that?
Can I get one of those?
I think I
Yeah,
handed one
right
back to
here.
Mrs. Miller. Okay, somebody remind me what I assigned yesterday. Page what?
387.
Is that due tomorrow or today?
323 odds.
I have 394.
I think it was 394, right?
Okay.
That's right. 387 was the one we turned in yesterday. Okay, what were the numbers on 394?
1 through 31 on.
Okay, 1 through 31 odd. Okay, now I've given you some graph paper. You might, the graph paper says 1 through 9, right? Obviously, if 17 says to put a graph there, then change one of those numbers to 17. I'm gonna make a change here. We're gonna make this due for Thursday now, okay? So you'll have some time to look at it. What I would strongly encourage you to do, take a look at this stuff tonight. Again, I know it's not the easiest stuff in the world, but I'll tell you, it might be the far most important stuff you're gonna have in order to be successful next year. So, look at it tonight. When you come back in tomorrow, be ready to fire off some questions for me,
Is this a
okay?
new assignment?
That's it right there, yeah. This is the only one, okay?
Take a look at. I
But-
bought that Baymax keychain from.
Did you change the due date?
Yeah, I did.
What's that?
It was Wednesday, it's now Thursday, okay? So anything that says to graph, where's this going?
There.
Okay, did everybody get a sheet of graph paper for that?
Yeah. Okay.
Okay. Good to go? Did she ask you to go somewhere, Mrs. Miller?
Actually, I think I already got that done and actually turned it in.
All right, stop recording here.